just been work with exponents or remembering a parent function. So as I walked around, it seemed like most people were pretty capable of this. So we should have had like 1/8, 1/4, 1/2, 1, 2, 4, and 8. Okay, so are we comfortable with those points for the parent function that's exponential? Okay, and what is the equation of an asymptote for an exponential function that's a parent function? If it hasn't been shifted or transformed yet, where's the asymptote for the function? Y equals 0, that horizontal line, okay? All right, so who can tell us how we can obtain the chart for the log function knowing that these are inverses? We can switch x and y, right? So basically, the things that we got out in the exponential function should be the things we want to plug in the log function. And then we should get the original inputs as our outputs. And then for those of you that are struggling, if that makes sense, remember a log is a question about which exponent you use. Think about putting 1/8 in here for x. What is log base 2 of 1/8? That's really asking you the question, what exponent would you use on 2 to get 1/8? And the answer would be -3, okay? So these would be, like we did yesterday, some of those log calculations that are just straight powers of that, okay? Is this all right with everyone? All right, so then what they look like, oh, well, we didn't do our asymptote. Any ideas what the asymptote would be before we go and try stuff? Yeah, it's going to be x equals 0, okay? Interesting. Because of that idea of being an inverse. So let's say I'm graphing this y equals 2 to the power of x function first. So we should be used to these by now. This should be review. It's an exponential parent function. So you're seeing things like this. All right. Now, if we go graph our log function, I'll graph that one in red, okay? This asymptote here. And then we have 1/8 -3, 1/4 -2, 1/2 -1, 1, 0, 2, 1, 4, 2, 8, 3. And notice, which we should see because we treated them as inverses to begin with, the idea that these reflect over this line y equals x. Okay? So a couple of notes about what this means about these functions before we get into like doing a Cartesian catalog with them and stuff like that. Remember our exponential function, the inputs could be any number because we can use any number as an exponent. Then we got the outputs, but they were restricted by this asymptote at y equals 0 because no exponent had the power to take a positive base and turn it into 0 or a negative. Is that okay with everybody? Why the asymptote for the exponential function was a horizontal line, okay? Blocking kind of a value below a certain thing because we couldn't obtain zeros or negatives with those parent functions. So what the graph of the log is telling us with this vertical asymptote here as a barrier is telling us we can't plug in an x of 0 or any negative x values in a parent log function, okay? So process that for a minute. Does it make sense that we can't plug a negative or 0 into this function right here, okay? So remember what it's asking. Let's try 0. Let's say I asked you guys to calculate log base 2 of 0. Okay, I would be asking you 2 to what power ends up equaling 0. And even though we can use any type of number as an exponent, they have limitations, right? If the base is positive, we said The whole reason our exponential function can't get to 0 or below is because there's no exponent that has the power to turn a positive number into 0 or into a negative. That means we'll never get anything here that will produce 0 or a negative over here, which means we can't plug in 0 or a negative into our log function because that's supposed to be the answer over here, but it's never going to work with the positive base. Is that okay with everybody? So our exponential function, we can plug in anything. The domain is all real numbers, but the range is limited because those exponents can't turn stuff into zeros or negatives. For the log function, the range is actually unlimited. It grows up and down and will reach all the values, high and low. But you can't plug in certain things because they're supposed to be the answer from the exponential function. Since the answer to the exponential function was limited, we can't plug in certain things to a log function. Is this okay with everybody? Right? So we're going to use our Cartesian catalog and go through and do the actual transformations with a log function now that we understand the basic parent. So our parents will look like this, and we'll talk about kind of two ways for you guys to build a parent function. One is kind of by memorization, so to speak, as far as what works really well. And formats for our parent function with log. So I'm going to show you how I write the parent function. We don't have to use quite as many points as we just put out on the screen prior. We still want to use those 5 values, but the thing is we can't plug in negatives and we can't plug in 0, right? So do you guys remember when we did the square root, how we adjusted what we plugged in because we couldn't just plug in -2, -1, 0, 1, 2. So this kind of has the same idea. We know that we can't just plug in -2, -1, 0, 1, and 2, okay? So we can't plug in negatives and zeros. 1 is the first good whole number to plug in. And what would log base 2 of 1 be? 0. Okay. And that's just like how every parent exponential function has 0, 1. Every log parent function will have 1, 0. And then the thing is we want a couple things around that because we want to see the curve go away from the asymptote and towards the asymptote. And this is kind of a nice like central point. So we want some things that are smaller than 1 and some things that are bigger than 1, but we can't have zeros or negatives. Okay, and then you really need to look at the base of the function that you're studying since it can change. This one's base 2, so I really want to plug in things that I know are powers of 2. So the things that are bigger than 1 that I would want to use would be 2 and 4, because those are powers of 2. And the things that are smaller than 1 that I would want to use would be 1/2 and 1/4, because those are powers of 2 with a negative exponent that's flipped them over to the reciprocal. So this is option 1 of how to get the parent function for a log function, is to basically understand that you want to use these values here because your base is 2. No zeros and no negatives. 1 kind of being the center and a couple things smaller than 1 and a couple things bigger than 1 based on this. If this was a log base 5, what numbers would I have used for my x values? 1/25, 1/5, 1, 5, and 25. Does everybody understand that pattern? So option 1 in learning the log parent function is like understand the log well enough to know what you want to put in there and then go calculate it and figure out what comes here. If you always choose these values based on the base, you should always get the same y values here. For example, 2, log base 2 of 2, what would that equal? So it's really asking you 2 to what power equals 2? So it'd be 1. What's log base 2 of 4? 2. What's log base 2 of 1/2? In other words, what exponent do you put on 2 to get 1/2? -1. Log base 2 of 1/4? -2. Okay. Okay, so that's option 1. I just know the log function well enough that when I look at the base, I know what values I want to use for the x. I know I can't plug in zeros and negatives. I'm comfortable with this, and I know that it has that limiting asymptote at 0 because I can't plug in 0 or negatives. Option 2 would be to do like a pre-step. We don't ever do this in here. We always do a parent. We do 2 charts when we're doing these problems, right? We do the parent, and then we do the transformed chart. Option 2 would mean you actually make 3 charts. You want a parent and a transformed chart. But if you don't understand this parent well enough to make it, you're going to do like a pre-step where you're going to think like, what if this was its inverse, an exponential function? like this, then I know that one really well. I plug in -2, -1, 0, 1, and 2. I get 4, 2, 1, 1/2, and 1/4. This is not the log parent. This is an exponential parent. But because logs and exponents are inverses, then all I do is take that parent function that I know really well and exchange x and y like you guys just did in what we were doing. Does that make sense to everybody? So if you're struggling with like, I am not going to be able to figure out and make this log parent function, my advice would be then when you're graphing logs, you're going to do 3 charts. A beginning chart that's not actually going to create your graph at all. The only purpose of making that exponential chart is to literally understand the parent function for the log, and then you won't use that exponential chart anymore. Okay? Is that all right with everybody? All right, so you guys already graphed this parent. So we're putting the same points we just put on our other notes on here. So 1/4, -2, 1/2, -1, etc. Okay. All right, so characteristics in this parent function. So you guys look at your graph. I know that when I scroll up, you're not going to see it, but you see it on your paper. Okay. So looking at your graph, what are our h and our k values for the parent function? H should be 0 and k should be 0, right? It's a parent function. There are no transformations there. Okay, x-intercept for this graph? 1, 0. Good. Okay. Y-intercept? None, right? That's where our asymptote is and our boundary saying we can't hit that or go over. What kind of transformation would we have to get a y-intercept? The parent functions don't have a y-intercept. If you want your graph to cross the y-axis, you're going to either have to have a shift to the left or a shift to the right with a reflection, right? Something like that. Okay. All right, domain for the log function. Okay. Good. X is greater than 0. If you like interval notation, that's from 0 to infinity. The 0 does not have a square bracket because we are not actually ever reaching 0. Okay. What's our range for the log function? All real numbers, okay, or -infinity to infinity. The graph does not turn around at any point, which means this entire graph is either increasing or decreasing. Which one in this case? Increasing. So the whole thing is increasing. And remember, you're listing x values for increasing intervals. So you're saying this graph is increasing from its beginning x value, from its lowest x value to its highest x value. And so that's the same as the domain. It's increasing from 0 to infinity, and there's no decreasing interval. Is it 1 to 1? Yes. Okay, it's a function and it's 1 to 1. The rate of change and axis of symmetry qualities are not applicable for this graph. Minimums and maximums doesn't have one. Okay. And then unlike the the exponential graph had a horizontal asymptote because it had a boundary, right, that they put across vertically so you couldn't go any further higher or lower. The log function, its range is all numbers, so there's no limitation going up or down. There's a limitation going left or right, okay? So there's a vertical asymptote cutting off our movement left or right, and in this case, that vertical asymptote is at x equals 0, and there's no horizontal asymptote. Any questions on the parent function for the log? And do you guys understand it won't always be log base 2? You can't look at this paper and just use the exact parent function I put here. If the base was different, you would have some different numbers in the parent function. Okay? All right, let's turn it over and do the more complicated example together. So first thing here, remember that we need to rewrite this function. Otherwise, we're not seeing the h value the way that we've studied it. Remember, we've only studied x minus h to say that a graph shifts left or right a certain amount. So when you put a 2 in front of that x, this is all of a sudden a new situation that you didn't study, and you need to rewrite it in the format you did study, unless you're going to go learn every possible situation, which is infinite and would be very impossible. Okay? All right, so parent function. This is log base 2, same as the one on the front page. And remember, you have two ways of coming up with your parent function. You either understand the log well enough to know which numbers to use, or you quickly go off to the side and make the exponential chart and then transform that into a log chart. Either way, we should end up with these. And remember that it originally has that asymptote at x equals 0. Are transformations that are happening here, okay? Horizontally, so the things happening to x are all happening in here. What are the two horizontal transformations? How would we say them? Okay, so verbally, what's happening horizontally? What do we have? Yeah. Okay, we have a shift right 2. So after whatever's done to x is done multiplying x, we're going to go plus 2. Does anything else have to be done to x? What's the second transformation? Yeah, no. Good. A horizontal compression. So x is going to get multiplied by 1/2 because of this 2 right here. All right, vertically, what transformations do we have? I see 3 vertical transformations. Okay, who can give us one of them? Yes. Good. So first there's a reflection over the x-axis, which means all the y's are going to have their sign changed. Okay, Noel? Good. There's a vertical stretch by 3 because of this 3 here. And what else? Andrew? Good. A shift down. Okay. So there's all my transformations that we said out loud verbally with the right vocabulary. And now I'm looking at how to calculate those points on the graph if I actually want to do those things to their distances. So we're going to go through and do these. So like 1/4 times 1/2 is 1/8 plus 2. It's nicer when they're all positive like that. It's just 2 and 1/8. And I'm just going to write it just like that. 1/2 times 1/2 is 1/4. And if I add 2 to that, I'm getting 2 and 1/4. 1/2 times 1 is 1/2 plus 2 is 2 1/2. 1/2 times 2 is 1 plus 2 is 3. And 1/2 times 4 is 2 plus 2 is 4. What will be my asymptote? So it should end up where? It was at 0 in the parent function, an x value of 0. So if it was exponential, you're right, because the asymptote is this way and we'd shift it this way because it was a y equals. But now our asymptote is this way and it's an x equals. So the only thing that's going to change it is shifting left and right. So it's going to be a 2. Okay, and so that's why I asked right here kind of on purpose, because with the x's we could transform it, or we can understand that it's with the transformation. Now I'm going to go through and do the y value. So if I plug in -2, I get 6 minus 1, so 5. If I plug in -1, 3 minus 1, 0, 1, and 2. And then I'm going to go ahead and I'm going to put these points onto my graph. Okay, so plotting your asymptote is nice. You should see all the points on one side of the asymptote, right? And then you should see one side curve towards the asymptote and one side curve away from it, just like you did with exponential, but oriented in a different direction. Okay, so x equals 2. Really close to 2. 2 and 1/8, comma 5. 2 and 1/4, 2. 2 1/2, -1. 3, -4, and 4, -7. And are we okay with how it looked? Because this one didn't look exactly like the parent function, right? The points were like kind of spread out. Does anybody know why that happened? What's causing that? No? Yeah. So because of the transformations, specifically the compressions and the stretches, because look what you did. Vertically, you stretched it out. So you already took it vertically and went like this. So does it make sense that it looks kind of flatter and less curved if we're going like this to it? Yeah. And then what did you do to it horizontally? Compressed it. So you squished it together like this and made it even flatter that way, right? So because they both kind of did the same, not the same in number, because they are in different directions, but both of them are causing the same effect, it like was kind of amplified when you see it on there, okay? All right, so why don't you guys take 10 minutes or so, and then we'll come back together 10, 12 minutes to finish the characteristics on this, and then go do the one that we haven't done yet on the other side as well, and then we'll check them together. So any questions about characteristics before we talk about intercepts? All right, let's look at intercepts. Okay, I'm going to look at the y-intercept first because the y-intercept is not about solving. The y-intercept is just about calculating because your equations are all written in a way that y is already by itself, right? Which means you don't have to get y by itself when you're solving for the y-intercept. It already is. That means you just have to know how to follow order of operations correctly over here to do a calculation. So when I plug in 0 for x here, the first thing I need to calculate is what's inside of the logarithm here in this parentheses. 2 times 0 would be -4. I know you guys can see on your graph that it doesn't have a y-intercept, but I want to show you why algebraically based on what we just talked about. That puts a -4 in here. So the y-intercept is -3 times whatever this logarithm calculates to be, -1. The problem is this logarithm is log base 2 of -4. Remember what we just talked about previously. That's saying 2 to what power equals a -4. We can't plug 0 or negatives into logarithms because they're defined with positive bases, and there's no answer because there's no exponent that would turn them negative. So having a log of 0 or a negative is an undefined value, which is why there's no y-intercept. And then you can see it graphically. And if you can see it graphically on a test, yes, just write none. You don't have to prove it to me this way. But what if I'm asking for you to solve for something later that's not in the context of a graph? I want you to be able to recognize something that doesn't make sense and you can no longer keep going mathematically, okay? All right, for the x-intercept, we do have to solve, which kind of puts us in a different spot here, okay? If I plug in 0 for y, here's my 0 for y, and here's the rest of my equation. The first things I do are just like everything else. If x is inside of a square root, I get the square root alone, right? If x is inside of a cube, I get the cube alone. This time x is inside of a log, so I get the log alone. So that's the first thing I do is just focus on getting whatever function contains x alone. So I added 1, and then I divided by -3, okay? I'm now at a spot where I have this crazy looking thing that says -1/3 is equal to log base 2 of 2x minus 4, okay? Let's say I gave you a simpler version, okay? 3 is equal to log base 2 of x. What is x in this problem? Good. Okay, 8 I heard. That's correct. Are you guys okay with it? Why it's 8? Why is it 8? Where are we getting 8 from? A base of 2 with an exponent of 3, because that's how these work, right? In other words, another way to write this is say I know my base is 2 and my exponent is 3, and that's supposed to come out to equal whatever x is. Fair? That I could rewrite that like that? So we're going to go more into this at a different place, but just to kind of preview it for you, this is a much more complicated version over here, but all logarithms can be rewritten in an exponential form, right? So I'm just going to go ahead and rewrite this in exponential form. 2 to the -1/3 is supposed to equal 2x minus 4. What is 2 to the -1/3? Well, it's 1 over the cube root of 2. Is that okay with everybody? The cube root is coming from the exponent of 1/3. The fact I put it 1 over is because the exponent was negative. How would you finish solving for x at this point? What are the steps you need to take to isolate x in this equation? Add 4 and then divide by 2. So as ugly as this looks, I get, and yes, I would expect something a little bit different from you, but for now, this is going to be okay. I would expect you to fix the radical a little bit. And again, I don't expect you to be an expert at this right now. We're going to do a whole section at the end by solving, but what better way to kind of get you like at least used to your options, kind of showing you some relationships right here. Okay. I don't expect you to be able to do all of the x-intercepts right now, but I do want to start showing you now so that later when we're solving, it might be more like review than a new idea. Okay. It's all right. It's a little bit tough. I know. Okay. So big main thing was this right here. This is new. Okay. After that is not new. That's new because it's saying this is how we change logs to exponents, etc. Okay. All right. Ready to look at it again in the other context? Okay. And again, I do expect more from us as far as leaving the radical in the denominator and stuff like that. But for now, we're going to leave it like that. As we get better at solving, we'll do more steps and worry about every little thing. Right now, I just wanted to introduce you to the idea that this is solvable, okay? But our brain has to understand this relationship. Our brain has to understand that when somebody's asking us to solve something that looks so unfamiliar and how would I ever know what's here, they're really giving us a base with an exponent that's supposed to equal something. And we have to kind of make that conversion in our head, okay? All right, let's go to the other graph. So let's check the graph first. So are we okay with what the graph looks like and where the points are, stuff like that, where the asymptote is? So any questions about the points or the graph or the asymptote? That's kind of our focus right now. All right, so let's do characteristics. I'm going to start at the bottom of the chart just so that we can save those x and y intercepts for last since they're kind of up at the top, right? All right, so the only asymptote we should see is our x equals -3, which is a vertical line and a vertical asymptote, okay? No other asymptotes, no minimums, no maximums, and axis of symmetry and rate of change aren't applicable for this problem, okay? So are we good with everything down from rate of change? Why the nuns are there, and why we have x equals -3 as our vertical asymptote. All right, 1 to 1, yes, it's 1 to 1. When you look at your graph, is the entire thing increasing or decreasing since we don't have a turnaround point? It's increasing the whole time, so notice I only wrote an increasing interval. Okay, and since x's weren't allowed to start until -3, like -3 is as far as we can go, that interval is from -3 to infinity. Okay, lowest x to highest x value. Right. All right, range is all real numbers. Okay, it's going upward and downward, whereas the domain is from -3 to infinity, or x is greater than -3. Right, and then our h and our k, our h is -3 and our k is 1. So for the y-intercept, this graph had a y-intercept, right? But it didn't come up in your chart and you couldn't see exactly where it crossed. So remember, you're not solving when you're finding y. Y has already been solved for, but you do need to calculate. So I plugged in 0 for x. I added up what's in here. 0 plus 3 is 3. And without a calculator and a formula, since we don't really have a button for this log on our calculator, this is as far as I can go. Okay? If this was a 4, I would expect you to go further. Do you guys understand my expectation? So basically, without a calculator, our expectation is if the log is something we can figure out, meaning if whatever's in here and whatever the base are can be written with the same powers like we did yesterday, then we should be able to calculate the log, even if it's a little bit difficult. However, if I look at the base of the log and what I'm trying to take the log of, and they cannot be related with the same base, then there is no way I can calculate it without a calculator. right? So 2 can be written as a base of 2, and 3 can be written as a base of 3. They don't have the common one. That's how I know I can stop here, and this is the most acceptable way for me to write this without having a calculator and doing a decimal approximation, okay? I know that this is something that's bigger than 1 but smaller than 2, right? Because 2 squared would be 4, so the log base 2 of 4 would be 2. Log base 2 of 2 would be 1. That doesn't guarantee that log base 2 of 3 is 1.5, because exponents don't necessarily work that way, but it's something in between 1 and 2, but I don't really know what it is, but that's the number that's here, and 2 times that plus 1 is what my y-intercept is, okay? But that is the most exact way for me to write it. Even with a decimal, you guys are not writing exact values at that point, you're estimating, because the decimal is like a never-ending, non-repeating decimal, so you would cut it off at some point, okay? For the x-intercept, you do have to solve. So like we said before, I put 0 in for y. And like with every other function, my focus would then be to get the function that contains x alone. So I subtract 1 and divide by 2, and I have this, okay? What can I do at this point to try and get x not stuck inside of a logarithm? What did we just see that we can do? Everything that's written as a log can also be written as an exponent. If you don't like the way it looks as a log and you can't finish it, and you feel totally stuck, then a course of action you should try is to take all that information but rewrite it in exponent form. It's the same information, but maybe in the other format I can keep going, okay? So I look at this and I feel stuck. I don't know about you guys, but I do, okay? I don't feel like I just know off the top of my head how to get x. If I feel stuck when it's in log form, then I go and rewrite it in exponent form. So in exponent form, the base is 2, the exponent's -1/2, and that's supposed to equal all the stuff inside the log. Now, I'm not saying it looks simple, it's still complicated, but can I get x alone now? Yes, so then this was a step in the right direction. So what is 2 to the -1/2? That's really 1 over rad 2, okay? And then I guess we'll simplify this one. We would multiply it by rad 2. So we would have rad 2 over 2. That's more politically correct, I guess, mathematically correct, okay? And then to get x alone, what do I need to do? Subtract 3. So again, it doesn't look pretty because we're leaving exact answers that have irrational things in them, so they don't look nice, because the only way to write this as a nice number is to put it in the calculator, get a decimal, and round that decimal at some point. Okay, if we want exact answers, this is as good as it gets. Okay, so this x-intercept is rad 2 over 2 minus 3, 0.